Well, hi, good morning. Thanks so much for joining me here in my shop. Hey, I think this might be one of the most exciting times I've had with a radio. I think that's what's about to happen here. So the reason for that is yesterday I spent about an hour getting this set up and getting it to work right so we can do what we're about to do. And I think what I'm going to be doing is going to expose a whole bunch about this radio. So now, having said that, usually what happens is within 10 minutes I'm knocked off course and everything goes crazy. So we'll see if that happens today. So what have I got on the screen there? So obviously in the top left is my oscilloscope, and in the bottom is my SDR radio. So let's, and this is off right now. I'm going to leave it off while I just tell you what it is I've got going here. So the scope is monitoring what amounts to the AVC voltage. The scope lead, you can kind of see it here coming to the volume control to pick that up. And you also see this wire going in there. This is the antenna lead to my SDR radio, which is in the bottom left you're looking at. And it's connected to the first tube in the radio. I'll show you on the schematic where it's connected. It's connected right here. So this is the front door of the IF. So basically by hooking up here, the SDR radio is looking at all the radio signals that are coming out of this tube. Now the only one that really matters to the radio is any signal that's at 460. 460 signals will go through the IF and come out the speaker. Everything else can be sitting here on the front door to the IF and not go anywhere because only 460 is going to go through. So it doesn't mean it's only 460 that's sitting here. What's sitting here is a whole pile of stuff that's come out of this tube. And I think by looking at this, it's going to give us a great impression of how this radio is working and allow me to perform some experiments. I have some interesting experiments in mind I want to try with this radio. And in order to get some kind of objective or some kind of even just qualitative, good qualitative information or even quantitative analysis, I need some way to monitor this radio. So I picked this way to do it. So let's turn on the radio and I'll show you what shows up on the SDR. Oh, I haven't finished talking yet. Whoops. So way behind the radio, is, it's a little hard to show you here, but back there is the my sweep signal generator here, and the frequency counter, which should be on. Now this guy is presently set to sweep through the entire broadcast band, so that's from about 530 up to about 1700, something like that, 1700 kilohertz. And it's sweeping through right now at a fast rate. I'm going to set it slow here. Set it to 1 second per sweep. Now you can see on the scope is now sweeping at 1 second. So the scope sweep here is controlled from the sweep generator. So what this really amounts to now is when the dot is over here, where it's showing any signal, any vertical rise is showing a signal at the low end of the AM band, 530, and at the high end would be 1700 kilohertz, and in the middle is somewhere around, I don't know, 900 to 800 kilohertz, something like that. So the whole AM band is stretched across here. So it would be interesting to see what that actually shows, which we will be looking at momentarily. And on the SDR, so on the SDR, we're going to try to see a number of things. I'm just going to have them come up, and then we can talk. Oops, and we can talk a bit about stumbling around in my shop here. Okay, let's flip on the radio. I've really been looking forward to coming in here and doing this. Since yesterday when I got this going and working the way I wanted it to, I just had no time to continue. So since then till now, I've been really waiting for this opportunity because I think I'm going to learn a pile of stuff. So let's look on the SDR. Something has changed dramatically there. Oh, something else is happening. Something is popping up on it. Why it's going up and down, you got me. Didn't even take 10 minutes. So the thing that is popping up is the local oscillator frequency of the radio. Just letting everything kind of warm up here. Now the radio is currently, so the antenna connection here is really going to the sweep generator. And the sweep generator is going at a very slow rate. Now I'm going to speed the rate up so fast that it's going to draw a continuous line on the scope, and it's going to change that SDR a lot. So let me speed this thing up. We'll go from 1 sweep a second to like 100 sweeps a second or something of that sort. Okay, now I'm going to raise the output level of the sweep generator. First I'm going to put the radio on full voltage here. Once again, exactly what's going on with that local oscillator, that's a weird thing. That was pretty strange. Now bearing in mind the SDR has a mind of its own, so look at that. Let's listen to the radio while it's doing that. Come on back. Oh well, it looks like there might be another problem with this radio. Let me just ignore that for a moment and turn up the sweep power and watch the SDR or the scope. We don't really need to listen to it. Now on the SDR, you've seen 2 more peaks pop up, and on the scope you see a dip here. But why is it so shaky? Something is a little awry here. Let's see if we can get, these things should be rock solid, so let's just see if we can find out what it is. Probably just a lead somewhere. Really shouldn't be moving around at all. Okay, we'll continue on. Maybe we'll knock the shakiness out of it. This should be rock solid. What are we really seeing now on that SDR display? Let's just go over it. First of all, this is the local oscillator. That's running around 1460, roughly. 1470, 1480. This is the tune point of the radio. This is the front end response. Now you got to realize the reason we can see this is because the radio receiver is receiving something on every frequency, because the sweep is sweeping through the entire AM band. The radio is seeing something periodically, every couple of milliseconds, every 10 milliseconds in fact. It's seeing a signal at any point you tune to. Now the SDR has a automatic volume control, level control, and it only responds so fast. So you certainly can't see 10 milliseconds of activity on the screen. So the SDR screen, probably for reasons I'm not probably nailing the reason for this, it shows the humps where the signal is affected by the radio as it sweeps through. And surprisingly enough, it shows everything you need to see to understand what's going on in this radio. So if I slow the sweep down, so now it's kind of jumping and popping around, and that's just the effect of the digital radio we're watching and how it analyzes the signal and stuff like that. You see the scope, it still shows you where it is. Now you're getting another effect on the scope, by the way. The dashing of the line is a visual effect from the camera shutter rate, or the camera frame rate, I should say. There's no shutter in those cameras. So I'm going to speed up the sweep again, so we get a nice smooth representation, especially on the SDR. So I said this was the front end tuning, and you'll see when I tune the radio, it moves. You notice there's a delay between my hand and what you see on the screen. The local oscillator moves. Some odd stuff going on with that. I don't know what to make of it. And this front end tuning point. Now the front end tuning point I'm going to set right on a million as best I can. I'm watching the SDR to do this. we looked, we'd probably find the radio pointer is pointing at 1 million, but we won't look just yet. That would spoil the surprise. There's more to know about what's on this SDR. So now if we look down here, we see another peak right here. Okay, so this peak represents the signal in the IF. Now we're ahead of the IF. This is looking ahead of the IF. So exactly why that's there, I can't tell you, but I'm pretty sure that's absolutely real. So in other words, what's happening in this radio is the local oscillator at 1500 roughly is being mixed with the signal, any signal coming in at 1 million, to produce a sum or difference frequency. I guess that would be a difference frequency of 460, which then passes through the IF. Now, some of you sharp-eyed people will be saying, you keep saying this 460, but that looks more like 500 on there. Yes, it does. And this is pretty much exactly where I stopped yesterday. Let's take a look at the scope signal. I'm going to shrink this down a little bit. That's nice and steady now. Actually, with my eye, this is perfectly steady, but on the image you're looking at, you see some flickering in here. That's just, again, it's just a camera effect. I see anything? Is that moving around? That's moving around. Well, we can't have that. It's actually moving around now. Okay, so anytime I do these complicated tests, which should go, you know, straight like an arrow, they never seem to. There's always little things happening here and there. Okay, let's go back to the SDR. We're going to analyze what the radio is doing precisely now. So if we look at the local oscillator frequency, I can get it by moving the, see that red line there? That's the SDR tune point. Now the SDR sound is off. We're not hearing it. So I can put that point right on top of here, like that, and then we can read the actual frequency to be written up here. 159. 1496. 1496. If we look down here, we see this is happening right at 1 million. It is because I put it there. Let's take a look on the dial and see if we're actually dialed in at 1 million. Parallax problems here. So you see we're just below it. We're about 980, I think that is tuned to. Wait a minute. Don't be fooled. We're actually tuned above by a little bit. Okay, that's that was like 10, looks like 10:20 a.m. is where we're tuned. We're not tuned to 1 million. Well, the dial doesn't say 1 million. That's true. But the radio is honestly electronically tuned to 1 million. You can see it right here. So if there was a signal at 1000 a.m., it would come out of the speaker of the radio. You know, I hooked it up to an antenna and changed all this around. But I have this equipment hooked up right now, so all you hear is this. Right. Now, if we look at this, this I said should be 460 kilohertz above this. This is 1 million. We add 460. We get 1,460,000, not 1,496,000. This appears to be 30 kilohertz high. Now I aligned the IF and I'm pretty sure I set it to 460 successfully. Followed the instructions properly. I isolated the instruments from the tuned circuits. There's no reason why it's not 460. Now look down here, looking right in the IF now, we see the IF peak is also not at 460, it's at 494. This has to occur exactly the IF frequency between this and this. But it really is supposed to be 460. 460 would be down here. You see, it's way off, actually. So what exactly is way off on this radio? So I'm going to guess that the front end tuning here is what's off. I'll have to move the whole shop down to 600. Still use the SDR at that point. Okay, everybody, we're heading for 600. Heading down. Okay, so that's... Actually, it's not so important where the radio is tuned, is it? I don't think it is. What's important is that I have this at 600. Right there. That's really 600. And yeah, because I'm looking at the SDR, I see there's a peak just below 600. So we want that to be at 600. I don't even have to do any of this, do I? I just have to turn the dial to 600 on the radio. On the radio here, as I've done, and then just adjust the L3. L3 is, oh yeah, here we go again. Not L3, adjust the B, C antenna 600. Antenna core 600. So most outboard, I believe it's this one actually right here. Only I adjust it from the top. All kinds of screwdriver problems doing this, didn't I? We can see all that stuff though. If I put the screwdriver onto the if it causes any effect, we should be able to see it on all this stuff here I've got going. So I'm just going to tap on and off the I don't see anything doing anything. Okay, let's go in there. I think what I'm going to do is I'm moving the peak that's down around 600. I'm going to put it right on 600. Anything moving? The local oscillator appears to be moving. I got the wrong control. Doggone it. What did I do wrong there? Yeah, I was on the wrong one. Duh. What a dork. So that's what happens when you do alignment. You make one mistake and you kind of throw it all into question. Let me work on the front here. We'll put the local oscillator back in a moment. Okay, now we're watching that front end peak down around 600. Stay in there. It's moving. Get right on 600. This will be one hot radio. Now the local oscillator may have gone off because I fiddled with it by accident. Which one did I fiddle with? Oscillator core 600 kilocycles. Well, good. So because we can see the local oscillator directly, I don't have to use the technique that's typically used to listen to the sound coming out of the speaker and just watch right on the SDR. So to tune in 600 with a 460 IF, you need 1060. So the local oscillator is at where is it here? Maybe it's right on. Well, I would say that's 1080. So I'm going to move it down a bit. Let me get on the incorrect thing here. Okay, now we'll move it. Went the wrong way. Wow. Okay, there we go. Moving it, moving it. You son of a gun, I forgot where I'm moving it to. .1060. That's where I'm moving. Okay, I put the red line on 1060 here. You see, we're a little off still. Oh, and wow! I just went and fiddled with another wrong control there. Come on, man. I'm too excited today. Okay, here we go. Wrong way, wrong way. On the right side of the SDR is a signal strength indicator. It says 69 on it right now. You can kind of watch that, almost like watching, you know, my meter down here in a way. So there we are. We now have the local oscillator correctly set to 1060. With a 460 IF, that should tune the radio to exactly 600. And should put a IF signal into the IF at 460. Okay, let's look at the IF. Now, there's two things going on here. That's pretty curious. This one, look, 460, right on the money. This thing, I don't know what that is. Get the IF all messed up? Maybe there's two peaks in the IF? This one is at 416, 420. 420? Hey! 420. Okay. Just gulping coffee here. Now, what can we do here? Let's try to figure out these two peaks in the IF. I'll probably end up messing up the IF tuning terribly, but I can always restore it. So I'm going to work from the top here because it's just a little safer. I'm going to go on the second IF, and I think this is the secondary of the second IF, isn't it? This actually says here. Secondary on the top, primary on the bottom. I want to do the primary, so I'm going to go in the bottom of the second IF. From some earlier experimenting not related to this, I kind of observed that when you're working with an IF, when you're working with an IF transformer, it looks like tuning the primary changes the tuning frequency, and tuning the secondary just raises the level up and down. That's kind of what it looks like. I don't know if that's really true or not, but based on that, I'm going to go after this coil. Way down in here among all these parts and wires and stuff. Okay, so what I'm hoping is the IF peak on the SDR to the left, but the main one is going to move. So something terrible happened in a place where I didn't expect anything to happen. Tune back. So the peak at 460 appears to be getting... This appears to be an ineffective thing. Think about it now, Jim. You're looking at the SDR before the IF. This is kind of a dumb approach. Yeah, hold it right there. This is where our scope is going to come in, because the scope is looking at the output of the IF, not the input. So look at that. Okay, excellent. Lots of weird things going on there on the scope here. It really changes the shape of the curve here as I do this. So, you know, how do you get the maximum? So if you're using a voltmeter, you can't see the shape change, you just see the indication on the meter going up and down. So, you know, where exactly is the peak? I'm going to guess it's here. But I'm not sure. That's pretty interesting. Certainly have messed up this IF, I bet. Let's think, what are we actually seeing here? So we're actually seeing the signal from the sweep generator as the sweep generator component outputs of the mixer tube are presented to the IF, and if there's one at 460, it'll make it onto my scope. Of course, there is one at 460. It's coming from the other signal generator. And actually, it's coming from both now. Where are they? Why have I got the other signal generator going at this point? Okay, the other signal generator is connected to nothing. So we're just looking at the sweep. Good. Okay. Good. And so this meter here is also this meter is also helpful in this deal. Maybe not, you know, because even though you hear that sound coming out of the speaker, there's actually no tone. So this meter is probably not going to move appropriately as I do the tuning. So to tune the IF, the best thing I can do, I think, is stick a 460 signal through it and tune it up, retune it up, because I messed it up, no doubt. You know, I made some component changes in here and a tube change in the back, and I'd really like, you know, perhaps this has been knocked off a bit. So to repeat that, we have to inject the signal. Inject the signal right back at the start here, right into the 6K7 grid cap. Okay, so to do that, we're going to take the sweep generator. You know, I can leave it connected. I'm just going to cut its output. There's nothing coming out of it, and we will put a 460 signal. Boy, there's too much to think about here. Into the cap. I need one of these. So we're going to want to look at the SDR. I'm going to have to keep that there. I got more of these guys here. Just trying to protect myself from blowing up my equipment. So this goes on to the grid cap. Don't go anywhere. Come back. That's probably not the best place to attach a ground either. Could go right here. And this goes on the grid cap. The signal's high. Down. Okay, watching the meter. .460, top of the same can. This will be the secondary. Watching the meter. Fell out. You know what? I'm gonna. So annoying. I got the proper tools for doing this. These aren't so hard to turn that I need to worry about the flimsy plastic. Okay, watching the meter. Oh, this is hard to turn. No, it's right on the peak. That's good. Now we're going to do the first IF. So we move the input terminal to, must be the grid cap of the 6K8. Doesn't really say, it just says 6K8. Grid cap 6K8. Down with the level. Over with the input. Freaked out by the sounds that come out of the radio. onto here. Okay, volume up. We don't hear anything. That's not right. I turned this down too low. I guess I did. Or it's way out of tune. Okay, now we're going to tune the first IF. Okay, watching the meter. What's happening here? The clip lead has just come. I have a clip lead on the plate circuit right above this. Going up. Hey, it's way off. Way off. Way the heck off. Holy smokes. Really? This is hard to believe. This was wrong coming out of the shop unless... Did I turn it that much when I fooled with it? Now that explains why there was two peaks in the IF. This was the other one. Wow! Wow! What went wrong with that? Component changes, tube changes. Maybe. Okay, so this should peak it up quite a bit too, I would think. This is the secondary side now. Oh, so stiff. Wow, this see, one of the funny things about radios is when they're not tuned very well internally, the result is the operator turns the volume up higher and gets pretty much the same thing. Not necessarily. Okay, let's try this screwdriver here. Oh, for crying out loud. Okay. I don't like to put my hand on it, but it was turned up and jammed against its end. Now that it's turned away from the end of its run, I can use this tool, and I'm pretty sure. Get the right one now. They're turning the wrong one. I think we're right at the peak. Wow, well that has made a huge, huge difference in this radio. So I'm gonna claim that the reason the IF was way off was not because I really blew it at the start, but blew it first time through. No, it's because I did component changes after the fact. That's my claim. Now what do we got? What have we got now? So much for experimenting. I'm just still in the process of tuning this radio up. Let's do this. We'll set the big frequency generator to any old. No. I gotta do the other end, man. I gotta go up to the other end, 1500. I almost forgot. Let's go up to the 1500. We'll do that. The fact that I did the IF in the middle of this, I don't think matters. That sounds like famous last words, doesn't it? Let me look at the. Let's get the. Let's put this guy back on here. He's not showing up. Okay, it's probably because that signal generator is. Okay, now we got both signal generators affecting this radio. We can turn this one up a bit. There, that's good. Strange stuff on the scope now. Still seeing two peaks in the IF of how'd that happen? See, one of those peaks in the IF is right on 460. Okay, I'm going to try this again, adjusting the IF. My assumption is one is tuned in one place and the other is tuned somewhere else. Can I figure out? So, I think, man, what are you doing here? Got this thing hooked up. Just get rid of that. Get rid of that and see what the radio looks like. Well, things have gotten a lot stronger on this thing, haven't they? Oh my gosh, it's totally different. Wow. Okay. See if we can analyze what we see on the SDR here. We don't have to listen to that. And the scope is pretty crazy looking too. Okay, I'm not going to analyze this yet. Let's start with the SDR. So first of all, a local oscillator appears to be this guy. This has to be the local oscillator. It's so powerful. And he's at 1060. Perfect. Because the radio dial is set to, oh, for God's sakes. Oh, wait a minute. 600 exactly. 600. It's set to exactly 600. So that should result in a, you should have, how can I put it? When the radio is set to 600 on the dial, the IF should be 460. Should be 1060, 460 on top of 600. Okay, so let's look at 600. What's going on here? Now, it's possible there's more than one signal entering into the radio. I don't think that's the case. It's interesting, the scope is also showing two things. Let me move that more in the middle of the scope. I just have to change the sweep range here a bit. It's getting more interesting. Let's change it a bit more. I can't. Not with the way it's, I can do this. There we are. So what? 1, 2, 3. What's going on? And this thing over here, something too. I'm not going to analyze that just yet. My head's full with this SDR screen. So, what's going on here? I don't know. Don't know. This is the front end tuning. This is the IF. Right at 460. These things could be coming out of the IF also. No. This is going into the IF. So this is what appears at the mouth of the IF. That's the way to put it. Don't know what these little peaks are here. These little things here. It might be noise. I don't know. Why wouldn't we just try tuning this radio now and be amazed at its capabilities? Well, what is there that's not working? Everything's working. Everything's perfect. I'm going to go up to 1500 and double check it all. Right. Okay, here we go. On our way to 1500. You get to watch all that stuff. You get to watch the scope and everything while I'm doing that. I don't know what happened. Some interesting stuff go by. I don't know. 1500 now. We're tuned to. So we'll tune. I don't need to tune anything. I just need to look at what's happened on the SDR. Isn't that right? Okay, we still hear the SDR going through the radio, so we're not out of range of the sweep. I'm sorry, the sweep going through the radio. I apologize now. I'm probably mixing up terms left and right while I'm talking here. Nothing new about that. What's next here? So we're trying to verify that everything is correct at 1500. So the radio is tuned to 1500. The local oscillator should be running 460 above that. 1960. 1960. That was a good year. Let's go right here. Check it. Looks like it's 1962. That's what it looks like. See the signal strength indicator right here. I go up another frequency. About the same. So we would want to adjust what? I want to adjust the local oscillator at this point. 3 out of 1960. 3 is pretty minor stuff. Okay, so let's see now. Where's the front end tuning peak? Where'd it go? It's supposed to be at 1500. It's supposed to be right here. I don't see any tuning peak. If I look at the IF now, 1460. Okay, that's good. So what happened to this? It disappeared. It should be here in the wrong spot at the least. So what I'll do is I'll adjust. Well, I can tune the radio and move it around and see if it shows up. Tune the radio and we'll see if we can spot something. Or another way, you know what? Another way is to pass a signal of 1500 through the radio and see if it doesn't peak up at the 1500 where it peaks up. All kinds, so many options, so many choices. Tune the radio, it's the easiest thing. So you see the local oscillator start moving, we look for something else moving with it. Not that thing that shot to the right. I don't see anything. Okay, so we'll tune the radio back to 1500 on the dial. Okay, that's 1500. That thing at 13, I don't know what that is. Some artifact that's occurred. It could be an SDR artifact or something in the radio. It's not near any critical frequency, so I'm not sure we should worry about it at all. It might even be, is it exactly 460 twice? 8, 9, 20? Is it 920 apart? So say 13. No, not 920. Don't know what it is. Well, I guess what we'll do is we'll tune the recommended thing here, C. So C5. Get it right this time, Jim. I don't want to make this wrong now. So C5 is another one I accidentally touched right in the middle there. I'll try not to boob it up this time. The one in the middle. The one in the middle. And you know, I should really be watching this meter. You know, that's not going to work. I don't think I can watch that meter and do this. So even though you hear stuff coming out of the speaker, it's not program material. It's the AVC circuits operating up and down quickly. Pulsing as the sweep goes through. I don't see how this can work, but I'm going to turn C5 and see if I'm just done. Okay, so we're on C5. I don't know what I'm expecting here. So I think this would move a peak around. There's nothing to see. Nothing to see here. Oh, look what's... No? I was going to say, look what's going on in the scope. But that's something else. Okay, so nothing happening here. This guy here. This has got to be a mica capacitor. Almost certainly its value is correct. able to peak this coil at the bottom with this inductor here. So we peaked it. This one doesn't do anything. Far be it for me to figure all this out, how all this is all connecting through these switches, and oh, smokes. What else could be wrong? That means that peak thing we can see when I tune the radio down. Let's get down there and make it show up. Okay, don't have the sweep going. Oh, I turned it off here. Sweep. Okay, so the local oscillator now is running basically 1140. It should always be 460 or very close. Yep. The radio is actually tuned to 675. That's that little peak right there. Why is it it's become so small? Wasn't it? It was really, really distinct before. Did that capacitor do that? So what can be happening here is you've got two adjustments. You've got an inductor and a capacitor. If one of them is way off, you can make them probably tuned in various places. There's probably various combinations that work. But you want the combination that's in the middle. And that's probably what's happened is, remember, I think I turned something a long ways here just a minute ago. That was an IF thing, wasn't it? Supposedly this shouldn't have much effect at the low end of the band, but it does. I've quieted everything down. I don't see any. So maybe all that's happened is just the more open I do this, the louder it gets. This is crazy stuff. Top end won't tune. Let's let's do that inductor again, and three. I think I'm going to move L3 around a bit. Goes to the front. Oh yeah, this is really hard to turn. That would usually mean it's at a limit. Oh wow. Did I move this? I can't even turn it. What's this thing here? Didn't I adjust it? I put the big screwdriver, my little screwdriver back in there. Oh my god. Where are we going? It's easy to turn with the screwdriver. we got into here today? I think the radio is much better tuned, believe it or not, for all this monkey business. Discovered the IF seemed to be way out, so I don't know why that happened. Probably component replacement. Ready for a little experiment here, are we? First thing we should do is listen to this radio on an antenna. Let's do that. Put that off there. Take this off, or else we'll be broadcasting a tone into the neighborhood. Bingo! Jimmy got a shock. Not watching what he's doing. Jimmy got a shock. Darn it. Not watching what I'm doing. Literally. Presence of mind is disappearing because I've been in here too long. I've had too many things go through my head, and I got all kinds of synapses now that are caught in various thinking loops and just off in the corner smoking, and my brain is drying out. Okay, let's get this off of here because there's so much stuff on here, and we're going to listen to it properly and take this off too. Don't get a shock this time. Oh, there we go. That was a B+ shock I got right off of this terminal. Oop. You didn't see any of that, did you? Right off of this terminal here. Had I been thinking a little more, then I wouldn't have got that shock. It's like a big green flag too, isn't it? There. Can't have that happen again. Now, went to my doctor yesterday. Heart is good. Just proved it here this morning. I'll call him up and tell him that. Okay, thinking, man. I really am worn out here. Get this off here. Get this all off. Get it off. Okay, now get it on. Let's get something on. So we're going to take this. We're going to hook it up to the antenna. Make that camera fall over. Nothing on that scope anyways. Nothing on any of that stuff. We're just going to tune this radio. Once I've convinced myself it's ready to go here. I'm going to have to run and turn this antenna on also. Let's get it on here. But my radio is hot enough now, and like it's sensitive enough now, it may work with almost no antenna. Famous last words. Okay, without being actually properly connected. Let me go turn the antenna on. I'll leave this up a bit. I'm just going to run through the house and flip a switch. Okay, what do we get? Sorry about that. I didn't have my antenna switched on in here. Okay, now we're cooking. surround sound is, but wow, it's just blaring in here. It's just wiping everything out. See the radio getting quieter? And I think that's indicative of what we were seeing on the SDR. I'm turning it up, that's it. Drat! I wish I knew what that noise was. It's coming right in on the antenna. I'm going to take the ground off. Sometimes don't ask me to explain why this is working the way it's working. It is. Why the ground on my antenna lead would do that? There's the noise anyway. Wow, I classify the operation of this radio as very poor now. I got my loop antenna in here. Let's try it out. Very, very poor. Just have to connect the ground here. Fall off. Come on. Hang on. Everybody hang on. So I think we were on a station there, weren't we? It's all going so quiet.
To Western Road Express and clusters are slow. The southbound 400 looks fine except onto the eastbound 401 ramp. That is backing up. On the eastbound 401 clusters from east of the 400 over to Kiel, that's a bit slow as well. Eastbound 407 east of Bramley Road, there was a ladder blocking the second or on the second lane from the right, or second lane from the left rather. That's eastbound 407.
Right. That's the problem.
Not already. I'll give them a call after this report.
The drooping pointer.
If that ladder is gone.
680.
Just be careful. Eastbound 407 east of...
But we do see the jobs. So, you know, in terms of August, they're losing over 80,000 jobs. So there's a disconnect between the unemployed and those that want to work and getting into the workforce. And that's what we're working on. And that disconnect is called red tape. It's all the rules and costs that the previous government imposed on businesses that can't afford to hire unemployed people. And the ones they do hire finally get through the red tape, they're paying them at least $14 an hour. That's what we hear. That's what statistics show. So
that's Jim Wilson, the Economic Development Minister, earlier this hour with me on the show. Simon in Toronto.
Well, the radio works great when given a good signal on the antenna. I'm going to fool myself if I rely on this indoor antenna, which some days is great and other days has this horrible interference on it. And I have no clue where it's coming from. It's probably something in my house. So, in terms of dial accuracy, well, one last thing. Let's see if we can measure the sensitivity of the radio since we know it's working well. The other thing, when I use instruments in here, signal generators, and I don't really know for sure how well a radio is working. I really need to try it out in an honest test. Now I got to figure out which one of these leads I want to use. We'll do this. I'll put this on. We'll just compare the signal, should be pretty quiet now. Good. So we'll dial down to, I'm just going to turn this off 460 a bit. We'll dial this down to the same frequency we're on now. Whoops. That was my antenna falling over. That's the IF. Okay, so what I've done, I can do it here. If you watch the meter here, see where it is? Now, my signal generator is pretty good. I can change the frequency and not change the output much. So we'll just jump up to the other end, 1500 now. See if it matches this spot. So on here, which scale do you want to use? Use any one. Just above the 1. Just above the 1. Okay, we'll dial around 1300 here. Okay. Now tune the radio to max the meter. And you can see it's definitely less. If I was to upscale a little more, I can actually get that in decibels. It would be the difference between -7 decibels and minus, it's hard to say, 11. That's 4 decibels. So less than half the strength. But the key thing about radios is we just compensate that way. Where are we on the volume control? Got a very strong signal coming in. Let's reduce it. Let's try this. One more test. Reduce the signal generator output frequency to the point where we can't hear it on the radio anymore. Then we'll go to the other end and see if we can hear it there with the same strength. That sounds like fun. Okay, so I'm going to turn this down. Can I still hear it? Let's just leave it like that. And get in your head what it sounds like. Off to 600. Okay, I'm right around 600. So the thing about the last test with the strong signal is the AVC is in there doing stuff. So see, at the low end of the band, the signal is really strong. The AVC is cutting it back. When we get up to the other end of the band where the response is weak, the radio automatically turns up its strength, fooling me into thinking it sounds pretty similar to either end. But this last test proved the front end is extremely sensitive compared to the front end. The lower part of the band is extremely sensitive compared to the upper part. So we're not done here. Something more is going on. Just what I wanted to hear.